Hello, good morning students. So let us carry on with lesson number 12, science, that is electricity. The lesson is on electricity and we were discussing this. Now I want you to understand those who are watching this video, okay, especially there are lots of students from other places also, and anyone who is watching, please subscribe to this channel and encourage this channel to grow. Also like the videos that you see, and that also helps in growing the channel. But most importantly, you must have noticed that the videos that I create are free for everyone. Okay, I have placed absolutely no restriction, absolutely none whatsoever. Any student, anyone from any part of the world is allowed to watch these videos, and there is no charge for that. The idea is to help people, especially in this pandemic, worldwide pandemic, to help students to learn from home. That is the only idea. So just encourage the channel by subscribing to the channel and also by liking the video, which helps this channel to grow quickly. Alright, that is about this channel. Now what do I intend to do in the next few weeks? You see, I have just learned that different schools are having different tests on different subjects. It's simply not possible to do simultaneously all the different chapters all at once. We can only do, that's why I'm doing one maths video and one science video every day, so that we can keep up. But even then, if different chapters are being done in different schools, it's simply not possible to keep up with that. Meanwhile, I just request you to watch the videos every day, make your notes, okay, and let me take you through, especially this chapter. You see, I'm going to take you through the whole chapter, but there are certain things which have to be taught with pen and paper, and therefore there will be one more or even two videos on electricity, which I will do just like the maths videos with pen and paper, so that especially the numericals, electricity, there are lots of numericals, and there is one derivation which I want you to understand thoroughly, and that is the Ohm's law derivation, which I will explain today, but that needs to be done with a paper and pen, so that you will be able to better understand it. So once I take you through the whole chapter, explain it to you, then I'm also going to do the numericals with the help of pen and paper, so that you actually see how the numericals are done. And I will also derive Ohm's law, because that is extremely important, probably the most important part of this chapter. Alright, so we have discussed so far about electric charge. Okay, the flow of electric charge is called current, how the electrons move. It is not fully understood as yet, although it is understood, but it is beyond the scope of this book to describe exactly how electrons move in a conductor. Okay, now let's go to the next part of the chapter, that is electric potential and potential difference. Alright, to put it very simple, just imagine you got a glass of water, okay, and you accidentally spill the glass of water in the kitchen. What happens? The water begins to flow. It is not going to remain in one place, unless of course there is a hollow or depression like a river or a lake or something. Then water will collect out there. If there is a slope, and generally in the kitchen there is a gentle slope which is almost invisible to the eye. The slope is towards the wash basin. Okay, the slope gently, ever so gently, is slightly towards the wash basin, and where there is a hole for the water to go out. Okay, so that is where the water begins to flow. It flows towards that. In other words, there is a gradient, a slope from a higher level to a lower level, which is very gentle, okay, and water begins to flow. Similarly, air mass also begins to move from high pressure to low pressure. That's how we get weather patterns. In the same way, for electric current to flow, there has to be a potential difference or a potential slope. Okay, so what is this potential and potential difference? You see, when a charge is brought from infinity to a point in the electric field, when a charge is brought from when in physics, you see, when we say infinity, it doesn't mean infinite distance, it means a large distance. Okay, so when a unit positive charge is brought from an infinite distance, a long distance, okay, to a point in the electric field, then the energy which is required, okay, to do that work is done, okay, against the electrostatic force of attraction. That is called electric potential. And if there are 2 points, then from point A to point B, the difference between the potential at point A and point B is called potential difference. As long as there is potential difference, current will flow in the circuit. If there is no potential difference, then current will not flow in the circuit. For example, take a battery. Okay, in a battery or your power cells, you see those cells which you use in your torch or even in a mobile phone. Mobile phone batteries are of course slightly different because they are lithium ion batteries, they are rechargeable batteries. But these batteries, you see, they've got chemicals stored in them. So energy is stored in the form of chemicals. Now when the wires are joined to the two terminals of the battery, the positive terminal and the negative terminal, then what happens is, because of the potential difference between the two ends, the electrons begin to move and current begins to flow. So there has to be a potential difference between the positive and negative terminal. Only then current flows, otherwise it will not flow. Now let's understand this in a slightly better way. What makes electric charge flow? Let us consider the analogy. Analogy means similarity of flowing water. Charges do not flow in a copper wire by themselves. See, if I take a copper wire, okay, and if I touch it, then nothing is going to happen to me because no current is flowing. Although copper is a very good conductor, but if I attach it to a power source, then because of the potential difference, now that wire becomes live, it is carrying current, and therefore it becomes dangerous. Charges do not flow in a copper wire by themselves, just as water in a perfectly horizontal tube does not flow. The water will lie out there, but it will not flow. Even in a river, you see there is a gradient, a slope towards the sea, and that is why water flows in the sea, in a river in a particular direction. As soon as water level goes down, okay, it is not able to flow, and at the same time, if there is no gradient, water won't flow. If one end of the tube is connected to a tank of water kept at a higher level, such that there is a pressure difference between the two ends of the tube, water flows out of the other end of the tube. For flow of charges in a conducting metallic wire, the gravity of course has no role to play. In this case, when water is flowing, gravity is pulling it downwards along the slope. The electrons move. For flow of charge in a conducting metallic wire, the gravity of course has no role to play. The electrons move only if there is a difference of electric pressure, which is called electric potential, called potential difference along the conductor. This difference of potential may be produced by a battery consisting of one or more electric cells. Okay, I'll explain cells and battery both to you just now. The chemical action within a cell generates the potential difference across the terminals of the cell, even when no current is drawn from it. When the cell is connected to a conducting circuit element, the potential difference sets the charges in motion. The electrons begin to move in the conductor and it produces an electric current. In order to maintain the current in a given electric circuit, the cell has to expend its chemical energy. It has to spend the chemical energy stored in it. That is why after some time it becomes discharged. फिर lithium ion cell को फिर से charge करना पड़ता है. Okay, your mobile phone is an example of that. We define electric potential difference between 2 points in an electric circuit carrying some current as the work done to move a unit positive charge from one point to the other. A unit charge. Okay, here just writing it here. Define electric potential. Define electric potential. Okay, state its units. देखो ये जो क्वेश्चंस लिखता हूँ, whatever questions I write here, okay, they are all written such that you can find the answer on that page itself. Okay, so here itself define electric potential and state its units. They are right here, which is underlined, and that is why I ask you to underline this or highlight it. Okay, we define electric potential difference between 2 points in an electrical circuit carrying some current as the work done to move a unit charge from one point to another point. Okay, generally it's a positive charge. Potential difference V between 2 points is equal to work done W upon charge Q, which is measured in coulombs. Okay, work done is always measured in joules. Charge is measured in coulombs. So joules per coulomb. Okay, so V is equal to W upon Q. Work upon Q means charge. Charge is measured in coulombs. Work in joules. Joules per coulomb. The SI unit of electric potential difference is volt, 1 volt, named after the Italian scientist, Italian physicist Alessandro Volta. In fact, Volta was the first one to make the Volta cell. Okay, that's all part of this chapter itself later on. 1 volt is, okay, just one second. Yes, The SI unit of electric potential difference is 1 volt, named after Alessandro Volta, an Italian physicist. 1 volt is now 1 volt is the potential difference between 2 points in a current carrying conductor when 1 joule of work is done to move one charge of coulomb from one point to another point. Okay, here are which instrument is used to measure potential difference between two ends of a wire. A voltmeter is used to measure potential difference. To measure current we use what is called an ammeter. करंट को मेजर करने के लिए एक इंस्ट्रूमेंट आता है, उसका नाम है एमीटर. इसी तरह से पोटेंशियल डिफरेंस को मेजर करने के लिए वोल्ट मीटर यूज किया जाता है. दोनों एक ही जैसे लगते हैं, उसमें देखेंगे तब पता चलता है एक में V लिखा होगा, एक में A लिखा होगा. A is एमीटर फॉर करंट, जिसमें V लिखा है that is voltmeter, and ammeter is always connected in series, whereas a voltmeter is always connected in parallel. Alright, but you see this difference, rather this definition. Again, you see these definitions have to be learned by heart. Okay. The other thing I want to tell you, in physics, you see a good question paper on physics is always set in such a way that there is some theory which involves such definitions. After that, there are some derivations, जैसे अभी आएगा Ohm's law. Okay. फिर उसके बाद न्यूमेरिकल्स होते हैं. So physics is always like that. Theory, then derivation of formula, and then finally another question on numericals, that is physical problems in physics, not physical problem but problems in physics. All right, so these kind of questions are generally asked in physics, where theory is always asked in one section of the question paper. It's important that you learn the theory also, and these are the definitions. So what is 1 coulomb, or rather what is one potential, what is 1 volt? How do you define 1 volt? Volt is defined as the potential difference between 2 points in a current carrying conductor when 1 joule of work is done to move a charge of 1 coulomb from one point to another point. 1 volt is equal to 1 joule upon 1 coulomb, and it can be written as 1 J/C, joules per coulomb. And this joules per coulomb is actually what? It is 1 volt. जूल पर कूलम अब कोई नहीं लिखता है. You don't write joules per coulomb, you write volt. Okay. The potential difference is measured by means of an instrument called a voltmeter, and voltmeter is always connected in parallel across the points with the potential difference is to be measured. For example, you see एक वायर है, उस वायर में से कितना potential difference है, अगर वो measure करना, if I want to measure the potential difference across a wire, then what I do is at the two ends I connect a voltmeter in parallel. That is the difference. Alright, so this is the difference between the difference between connecting a voltmeter and ammeter. Alright, now there are some numericals. Okay, as I told you, electricity में numericals है, physics में हमेशा numericals होते हैं. Numericals का marks होता ही है, and you will have to learn how to do it. Now these, of course, I told you I need a pen and paper to do it. In one video, after the chapter is over, I will do this electricity numericals. I will do a lot of them, all which are given in the chapter and at the end of the chapter, so that you get an idea how these numericals are to be done. Also, I will derive Ohm's law also on the piece of paper, so you understand it better. Alright, just see this example 12. How much work is done in moving a charge of 2 coulombs across 2 points having a potential difference of 12 volts. So V, capital V is equal to 12 volts. Okay, coulombs of charge, 2 coulombs of charge. Q is equal to 2C, 2 coulombs of charge, and you want to find how much work, W निकालना है. So the formula is the same one. Okay, V is equal to W upon Q, or W is equal to V multiplied by Q. Put the values 12 to the 24 joules. Work is always measured in joules. So 24 joules. You see, these numericals are not difficult. They are formula based. Okay, and they are quite easy also. But unless you know how to do them, unless you practice them, you will never know. Alright, all these questions are there in the PDF, which I will send to you later after the chapter is over. The previous chapter which I did, okay, metals and non-metals, I think I will not send the PDF. I will send it today. By evening, I will send it today. Alright, circuit diagram. Okay, these PDFs, of course, with detailed question answers, I will be sending to those who have subscribed. Okay, they will get it. And there are some students who are, I don't even know whether they will subscribe. Once you subscribe and make it public, I know about it, and I can send you the PDF also. I want to encourage you to do well, and that is why I am asking you to subscribe as much as possible. Circuit diagram. We know that in electric, now what is the circuit diagram? In electricity, you see, we always make diagrams. But the diagrams that we make in electricity are generally called circuit diagrams. Okay, circuit is nothing but a schematic diagram which shows how current flows from where to where. Okay, the source of current must be a battery or the main supply. वहीं से करंट निकलता है, फिर कहाँ जाता है करंट. Okay, that is what a circuit diagram is all about. We know that an electric circuit as shown in figure 12.1 comprises, it is made up of what? A cell, that is a battery. Now some of you may ask a question, cell और बैटरी में फर्क क्या है? Cell is a part of a battery. बैटरी अगर 6 वोल्ट्स की बैटरी है, बड़ी 6 वोल्ट्स की बैटरी है, तो इसमें डेड 1.5 वोल्ट्स का एक सेल होता है, 4 सेल. If 4 cells are there, each one of 1.5 volts, then you get a 6 volt battery. Okay, electrical components and connecting wires, it is often convenient to draw a schematic diagram, a scheme in which different components of the circuit are represented by symbols conveniently used. Conventional symbols used to represent some of the most commonly used electrical components are given in table 12.1. Now you see this table. Now there is no need to learn it by heart, but it is better you do, because sometimes you see MCQs, single line questions can be asked. What is this symbol for? What is that symbol for? Now see an electric cell. You see, when you look at the first symbol, you take a positive terminal and there is a negative terminal. Those are the two ends of a cell. अगर ये 1.5 वोल्ट का सेल है और ऐसे 4 सेल को सीरीज में लगा देते हैं तो आपको 6 वोल्ट की बैटरी आ जाती है. So this is not a symbol for a battery. Battery can have, see the next one, for example उसके बाद वाला second one देखो, a battery or combination of cells. देखो ये इसमें है 1 2 3 4, okay, 4 vertical lines देखो, एक vertical line और एक positive line और negative line, okay, small line is a negative line, big line is a positive line, positive terminal, negative terminal. एक positive terminal और एक negative terminal मतलब एक cell. पॉजिटिव नेगेटिव, इसमें 3 सेल है, 4 नहीं है. तो फॉर एग्जांपल अगर 2 वोल्ट का एक सेल है तो 6 वोल्ट की बैटरी हो जाएगी, क्योंकि इसमें 3 सेल्स है. अ बैटरी ऑफ कॉम्बिनेशन ऑफ सेल्स, प्लग की और स्विच, बट इट इज ओपन. ओके, थर्ड और फोर्थ देनो. सी द फोर्थ वन इज क्लोज्ड. ओके, इसमें यू कैन सी अ ब्लैक डॉट, इट मींस द सर्किट इज कंप्लीटेड. स्विच को ऑन कर दिया. थर्ड में स्विच इज ऑफ, ऑन नहीं है, ओपन है, इट इज ऑफ. अब वायर जॉइंट, कहीं से भी हम जो वायर का जॉइन करते हैं, इट इज शोन लाइक दिस. ओके, वायर्स क्रॉसिंग विदाउट जॉइनिंग, एक के ऊपर से. देखो ये 5th और 6th में डिफरेंस देखो, एक में एक्चुअल जॉइंट हुआ है वायर्स को, और 6th में वायर्स को ओवरलैप किया है. दे आर नॉट जॉइनिंग ईच अदर, दे आर जस्ट पासिंग ओवर ईच अदर. देन 7th वन इलेक्ट्रिक बल्ब, इसमें 2 सिंबल बताए गए हैं, एक बल्ब जैसा ही है, it looks like a bulb. The first one doesn't look like a bulb, but that is the one which is drawn in the circuit. The second one जो actual bulb दिखता है ना, वो generally ऐसा circuit में कोई बनाता नहीं है. The first one is the symbol for a bulb, and that is widely used in a circuit. 8th one देखो, that is a resistance or a resistor. Okay, wavy line resistor, 10 volts का resistor, 5 volts का resistor, 2 volts का volts क्या, ohms. Okay, 2 ohms का resistor, 5 ohms का resistor, 3 ohms का resistor, it can be of any ohms, but resistor is shown with a wavy line. Okay, variable resistance और rheostat. अब ये variable resistance या rheostat का symbol देखिए, एक वहां पे arrow है. Okay, and or you can do the second one. Both are equally common, दोनों को use किया जाता है. But the difference here, 8th और 9th में actually difference क्या है? Difference is 8th में आप रेजिस्टर जो है 5 ओम का अगर रेजिस्टेंस है तो वो ओम को आप 5 ओम को बदल नहीं सकते. यू कैन नॉट चेंज द रेजिस्टेंस इन नंबर 8. इन नंबर 9 यू कैन एक्चुअली चेंज इट. जैसे रियोस्टेट उसको ब्रिज रियोस्टेट भी बोलते हैं. इट लुक्स लाइक अ ब्रिज, इसलिए उसको ब्रिज रियोस्टेट बोलते हैं. और उसमें एक स्लाइडर होता है, स्लाइडर, इट स्लाइड्स अप एंड डाउन. स्लाइडर, उस स्लाइडर को चेंज करके आप रियोस्टेट में रेजिस्टेंस है वो इंक्रीज भी कर सकते हो, डिक्रीज भी कर सकते हो. इट इज अ रियोस्टेट और अ ब्रिज रेजिस्टेंस और अ ब्रिज रेजिस्टर. There is a slider and with the help of that slide you can either increase the resistance or you can decrease it. और वो जो स्लाइडर है उसको एरो की तरह दिखाया है. That is where you can increase or decrease. That's why it's called variable resistance or a rheostat. Then a symbol for ammeter, it measures current, देखो प्लस और माइनस. एंड वोल्ट मीटर फॉर मेजरिंग पोटेंशियल डिफरेंस अक्रॉस अ रेजिस्टर. V का सिंबल है प्लस और माइनस. एमीटर ऑलवेज इन सीरीज, वोल्ट मीटर ऑलवेज इन पैरेलल. Alright, now we come to the most important part of the chapter, जो बार-बार हर साल प्रैक्टिकली पूछा जाता है. See the question there. state and derive or state and explain Ohm's law. Okay, Ohm is a name. Okay, it is nothing to do with religion or anything. It is a name of a German scientist, a German physicist. State and derive Ohm's law. जब ये derivation करते हैं 3-4 मार्क का होता है. So what you do is give the statement first, statement of Ohm's law, then make the circuit diagram and then explain it and derive it. And इसमें अगर possible है अभी एक ग्राफ भी आएगा, वो छोटा सा ग्राफ वो भी दिखाना चाहिए, because ये 3-4 मार्क का क्वेश्चन होगा. Okay, is there a relationship between potential difference V across a conductor and the current I flowing through a conductor? Is there some relationship between that? Okay, a German scientist wanted to know if there is some relationship, and he conducted an experiment which is famously known as Ohm's law experiment. Okay, and he found out that there is a relationship between the potential difference across a conductor and the current flowing through the conductor. और अच्छी जब activity 12.1 है. Yes, set up a circuit as shown in the figure consisting of a nichrome wire. Now what is a nichrome wire? Nichrome is an alloy. Okay, it's a special kind of alloy used as a conductor, used as a resistor in physics, and it is made of nickel and chromium. Generally nickel और chromium, इसमें कभी-कभी manganese भी add कर देते हैं, iron भी add कर देते हैं, but it is more than 99% nickel and chromium, and that's why it's called a nickel alloy or nickel chromium alloy or a nickel or simply a nichrome wire. Okay, nickel and chromium alloy. So this wire is used as a conductor. First, use only one cell as the source in the circuit. Note the reading in the ammeter I. Because I used red arrows just to show it to you. Okay, see there is a battery. The battery has got 4 cells, 1, 2, 3, 4 cells. Okay, variable battery, in other words, you can change the number of cells. Suppose एक cell का voltage है 1.5 volts. 4 of them together will give you 6 volts. You add 2 and you get 3 volts. 3, 4.5 volts. चारों चार को लगा दो, you get 6 volts. Okay, and then you got nichrome wire. Okay, between X and Y. Between X and Y there is a resistor R. That R is a nichrome wire. There is an ammeter in the circuit. Notice its position. There is a key which is, in this case it is shown closed. मतलब current is already flowing, and of course the current is flowing from the positive to the negative. Okay, always from the positive. See the direction here. This is the battery or the cell. Current is going to flow in this direction, anti-clockwise direction. Anti-clockwise direction. Okay, anti-clockwise. This way. It is flowing in this direction. Now you can measure the current flowing through it, and you can also measure the potential difference V across the ends of the conductor. But you can vary the potential difference. You can vary it by changing the number of cells. First, use only one cell as the source in the circuit. Note the reading in the current, that is ammeter for the current, and reading of the voltmeter for the potential difference across the wire. And then tabulate it in a table. Potential difference V volts, current I amperes. Next, connect 2 cells now and then perform the same experiment. Then you can connect 3 cells and perform the experiment. Okay, and you must take readings for all of them. When you take readings, okay, you can put it in a table like this, and you can see the table. Serial number 1, 2, 3, 4. Number of cells used in the circuit, 1 cell. Okay, so the potential difference. Okay, look at this, the potential difference. The potential difference across the nichrome wire V volts. This is the first one. Okay, the first one will be 1.5 volts. In the second one, it will be 3 volts, then 4.5 volts, and finally 6 volts. Okay, चारों चार को लगा देते हैं तो current will change accordingly. Okay, potential difference such that the potential difference increases, current will decrease. Okay, such that V upon I will be constant. ये जो रेशियो निकलता है V upon I, करंट थ्रू द नाइक्रोम वायर एम्पियर्स में मिलेगा. वो एम मीटर में से उसका रीडिंग देख लो कितना है. नीडल फ्लक्चुएट होता है एम मीटर में, उसका रीडिंग ले लो. नाउ यू सी आफ्टर दोस यू मेक द रेशियो ऑफ V upon I. V upon I का रेशियो देखो, you will find that it is a constant. Okay, अगर all the other factors, that is the temperature etc. being constant at room temperature, this ratio of V upon I will be constant, and this was first observed by a German scientist. Alright, see here. In this activity you will find that approximately the same value of the ratio V upon I is obtained in each case. Thus V to I graph, okay, voltage potential difference against current if you make a graph, is a straight line that passes through the origin of the graph, and therefore V upon I is constant. Alright, see here, if you look at this graph out here, see, I have written a question, this graph must be shown. When you write 3-4 marks का question है, state and explain Ohm's law, उसमें ये graph बनाना बहुत easy है, you should make it. Alright, see the current I on the x-axis. On the x-axis you can see current I. Alright, and on the y-axis, vertical axis, potential difference in volts. Current in amperes, potential difference in volts. उस जो reading मिला हमको, okay, ऊपर के टेबल में अभी उसका ग्राफ बना लो. You can see this. The cross mark, first reading, second reading, third reading, fourth reading, fifth reading, sixth reading. Make a चार reading का graph बना लो, and you will get a roughly you will get a straight line. You may not get an exact line because you see there are other factors which influence. For example, the resistance of the wire, okay, the resistance of the circuit itself. Then you will also see factors like temperature of the room. All these things they affect the current flowing and the resistance. So you may not get a perfect line, but generally it is quite a perfect line. Okay, passing through the origin, the blue line graph. The slope of this line will give you the ratio of V upon I, and that will give you the resistance of the conducting wire. In this case, the nichrome wire. Alright, in 1827, a German physicist by the name of George Simon Ohm, although it is Georg, not E, it is still pronounced as George Simon Ohm, found out the relationship between the current I flowing through a metallic wire and the potential difference across the terminals, that is positive negative terminals. The potential difference V across the ends of a given metallic wire is in an electric circuit is directly proportional to the current flowing through it, provided its temperature remains constant. Okay, at constant, वही constant temperature होता है room temperature. This is called Ohm's law. Okay, now I have written the question here. Statement of Ohm's law. Okay, it's not a question, but I am just drawing your attention to it. This is the statement. The potential difference V across the ends of a given metallic wire in an electric circuit is directly proportional to the current flowing through it, provided its temperature remains the same. This is called Ohm's law. Okay, that is the statement of Ohm's law. इसलिए जब ये क्वेश्चन आता है तो पहले ये स्टेटमेंट लिखना चाहिए. स्टेटमेंट के बाद सर्किट डायग्राम बना चाहिए, फिर उसको एक्सप्लेन करो. वो टेबल जो है टेबल भी बना सकते हो और ये ग्राफ भी बना सकते हो. 3-4 मार्क के लिए लंबा आंसर होना चाहिए, सब्जेक्टिव आंसर है. ऑलराइट, देन इन मैथमेटिकल फॉर्म दिस इज कॉल्ड Ohm's law. इन अदर वर्ड्स V is proportional to I. देखो वो सिंबल है, इट इज प्रोपोर्शनैलिटी सिंबल. V proportional to current I, or V upon I is always constant. The ratio of voltage upon current is always constant, and this constant is called the resistance of the wire, the resistance of the resistor or conductor, and V is equal to I into R for all other factors being constant. So V is equal to I into R in equation 12.4. R is called the constant for the given metallic wire at a given temperature and is called the resistance of the wire. देखो, for the given wire, ये वायर कौन सा था? नाइक्रोम वायर. ओके, उसके लिए कॉपर वायर अगर उसकी जगह पे इफ यू यूज अ कॉपर वायर द वैल्यू ऑफ आर वुड बी डिफरेंट. If you use aluminum wire, the value of R would be different. In fact, different materials, different conductors have different resistivity. We'll come to that topic later on. Resistivity. What is resistivity? Every single material, copper, aluminum, and so on, they have resistivity. That resistivity shows whether it's a good conductor or a poor conductor. Lower the resistivity, the better the conductor. For example, copper, aluminum, iron. Okay, these metals are good conductors of electricity, and the resistance is very low. The resistivity. Okay, the resistivity is a characteristic property of the material. Resistance is different and resistivity is different. Resistance का symbol R है और उसको ohms में measure किया जाता है. Resistivity is characteristic of the material like copper, aluminum. Each one has got specific resistivity, जैसे density होता है. And resistivity का symbol rho है, that is slightly like P. And उसका जो units है, it is measured in ohm meters. In other words, it is slightly different. Okay. Now see, it is and is called as resistance. It is the property of a conductor to resist the flow of charges through it. Its SI unit is ohm, represented by the Greek letter ohm. Just like you have the alpha, alpha, beta, gamma, delta, theta. Those are all Greek letters. This is one more Greek letter. This is called ohm. Okay. According to Ohm's law, R is equal to V upon I. This is a very important question. This R is equal to V upon I is something that you must memorize, because you see this will be used in our numericals, often in numericals. If the potential difference across the two ends of a conductor is 1 volt and the current flowing through it is also 1 ampere, then the resistance of the conducting wire is said to be 1 ohm. That is 1 ohm is equal to 1 volt upon 1 ampere. Alright, just one question, I'll write it out here. Define ohm, okay, or the unit of resistance. It is the same thing. Define ohm or define the unit of resistance. The definition is here. Alright, the definition, define ohm or define resistance. Okay, here. If, see, this is the definition. If the potential difference, okay, if the potential difference across the two ends of a conductor is 1 volt and the current through it is 1 ampere, the resistance R of the conductor is 1 ohm. That is, this is part of the definition, that is 1 ohm is equal to 1 volt upon 1 ampere. That is the definition of ohm. Also from this equation, I is equal to V upon R. Because R is equal to V upon I और I is equal to V upon R is the same. और एक ही याद रखो, R is equal to V upon I. So उसमें से अगर दो दिया है, R और V दिया है, तो I निकाल सकते हो. V और I दिया है, तो R निकाल सकते हो. It is obvious from equation number 12.7 that the current through a resistor is inversely proportional to its resistance. Sorry. करंट थ्रू अ रेजिस्टर इज इनवर्सली प्रोपोर्शनल टू इज रेजिस्टेंस. उसका मतलब क्या है? अगर रेजिस्टेंस ज्यादा है तो कम करंट फ्लो करेगा, अगर रेजिस्टेंस कम है तो ज्यादा करंट फ्लो करेगा. फॉर एग्जांपल कॉपर और एल्यूमिनियम आर सेड टू बी गुड कंडक्टर्स ऑफ इलेक्ट्रिसिटी. व्हाई? क्योंकि उसका रेजिस्टेंस कम होता है. इसलिए फॉर एग्जांपल रबर इज एन इंसुलेटर. इसका मतलब है उसकी रेजिस्टिविटी बहुत हाई होगी, इसलिए करंट निकलता ही नहीं उसमें से. करंट डज नॉट पास थ्रू रबर दैट वे. ओके, so if the resistance is double, the current flowing through it gets half हो जाता है. रेजिस्टेंस को डबल करो, करंट आधा हो जाता है. more the resistance, less the current. In many practical cases, it is necessary to increase or decrease the current in an electrical circuit. A component, a part, electrical part used to regulate current without changing the voltage source is called variable resistance. उसको हम rheostat भी बोलते हैं. Variable resistance or rheostat. Okay, again I'll write something out here. Okay, variable resistance or rheostat. It is called a variable resistance or a rheostat. Okay, variable resistance or a rheostat or a resistance bridge. Sometimes it is also called or a resistance or a bridge resistance. Okay, इसको कभी कभी ब्रिज रेजिस्टेंस भी बोलते हैं, बिकॉज इट इज लाइक अ ब्रिज. ब्रिज की तरह उसका शेप होता है. फिजिक्स लैब में आप देख सकते हो. ओके, एंड ओके, वी विल नाउ स्टडी अबाउट इलेक्ट्रिकल रेजिस्टेंस ऑफ अ कंडक्टर विद द हेल्प ऑफ द फॉलोइंग एक्टिविटी. ऑलराइट, सी आई विल जस्ट एक्सप्लेन दिस टू यू एंड देन वी विल गो थ्रू इट लेटर, बट लेट मी जस्ट एक्सप्लेन. सी फॉर एग्जांपल, look at this simple circuit, activity 12.2. sorry, there is a battery, okay, not a cell. Remember, usme if you count it 1 2 3 4, there are 4 vertical lines. Okay, large lines are 4, that means 4 cell है. 1.5 volt के 4 तो 6 volt की बैटरी हो गई. There is a key, in this case it is closed key. Then of course there is an ammeter and then there is XY. Through that point XY you can connect anything. ओके, ओपन एंड है एक्स एंड वाई. एक्स एंड वाई में आप एक रबर भी रख सकते हो, उसमें एक एल्यूमिनियम वायर भी रख सकते हो, उसमें कॉपर वायर भी रख सकते हो, नाइक्रोम वायर भी रख सकते हो, और उसमें एक बल्ब भी लगा सकते हो, ट्यूबलाइट भी लगा सकते हो. ट्यूबलाइट तो नहीं लगा सकते हो क्योंकि ये बैटरी है, 6 वोल्ट की बैटरी है, उसके लिए छोटा सा बल्ब चलेगा. बट अ लार्ज substance will not be able to pick it up or it will not be able to work properly because the potential difference is too low. 6 volts is only for small things. So इधर हम एक्स वाई के ऊपर नाइक्रोम वायर लगा देते हैं. ओके, यू कैन सी नाइक्रोम वायर बाजू में दिखाया. 10 वोल्ट का बल्ब दिखाया, 10 वोल्ट का बल्ब, जैसे नाइट लैंप का बल्ब होता है. नाइट लैंप का 0 वोल्ट का होता है, जो छोटे बल्ब लगा दो. ओके, बैटरी का बल्ब है वो सबसे बेस्ट है. देन टॉर्च बल्ब. द टॉर्च बल्ब, जो बैटरीज होती है, हमारी टॉर्च है, उसका बल्ब है वो आइडियल है, परफेक्ट है, बिकॉज उसका वोल्टेज या उसका वोल्टेज बहुत कम होता है. नाउ यू कैन यूज एनी वन ऑफ दोस 3 or 4 different things. Okay, and you can see किस में करंट पास होता है कि नहीं होता है, ओके, हाउ डज इट वर्क। और इतना ही नहीं, अगर एक एमीटर लगा देते हो तो कितना करंट उसमें से पास करते हैं वो भी हम देख सकते हैं। नाइक्रोम वायर का रेजिस्टेंस पता चल जाएगा, बिकॉज नाइक्रोम वायर इज अ गुड कंडक्टर, मोर करंट विल पास थ्रू इट, उसका रेजिस्टेंस लेस है, ओके। इसी तरह से अगर बड़ा बल्ब लेते हैं तो रेजिस्टेंस हाई होगा, स्लाइटली लेस करंट विल पास थ्रू। छोटा बल्ब लेते हैं, उसका रेजिस्टेंस कम होगा, मोर करंट विल पास थ्रू इट। इन अदर वर्ड्स, यू कैन एक्चुअली मेजर द करंट passing through it by using an ammeter, and this will actually show you that different substances have got different resistivity. Okay, the internal structure of the substance is such that it offers resistance to the flow of current. All substances do not offer the same resistance, they have got variable resistance. Copper का resistivity अलग है, एल्यूमिनियम का that property is called resistivity, और सबका प्रॉपर्टी अलग होता है। फॉर एग्जाम्पल, कॉपर रेजिस्टिविटी एंड एल्यूमिनियम रेजिस्टिविटी इज क्वाइट लो, इसलिए दे आर वेरी गुड कंडक्टर्स, ओके। नाउ just to go ahead with this experiment, complete the circuit by connecting nichrome wire, plug the key and note down the reading in the ammeter how much current is flowing through it, okay. Replace the nichrome wire with the torch bulb, ओके। पहले तो सर्किट कंप्लीट नहीं करनी, पहले क्या करना चाहिए, पहले की को उठा लेना चाहिए, सो सर्किट ब्रेक हो जाती है, फिर नाइक्रोम वायर को निकालो। Replace the nichrome wire with a torch bulb in the circuit and find the current passing through the ammeter. Similarly, repeat it with a 10-volt bulb and see how much current is passing through it. Remember, इसमें हमने 6 वोल्ट की बैटरी, वोल्टेज तो कांस्टेंट है, V, value of voltage V is equal to 6 volts, okay, potential difference, there is no change there. सर्किट में भी कोई चेंज नहीं है, सिर्फ रेजिस्टेंस को चेंज किया है, ओके। एक में ज्यादा रेजिस्टेंस है, एक में कम है। नाइक्रोम वायर में कम रेजिस्टेंस है, ज्यादा करंट फ्लो करेगा। इन दिस एक्टिविटी वी ऑब्जर्व द करंट इज डिफरेंट फॉर डिफरेंट कंपोनेंट्स। Why do they differ? Because of the internal resistance of the substance. Certain components offer an easy path to the flow of electrons, while to the flow of electric current and electrons, while the others resist the flow of electrons and electric current. We know that motion of electrons in an electric circuit constitutes electric current. Electrons should be able to freely move. The electrons, however, are not completely free to move within a conductor. There is certain resistance. Like पानी, जैसे अगर मान लो पानी बह रहा है रिवर में और आगे एक चेक डैम आ जाता है तो पानी कैसे ब्लॉक हो जाता है, इसी तरह से they are restrained, they are stopped by the attraction of atoms which they move. Atoms have got positive and negative charges, and there is intramolecular or intraatomic force of attraction. उसको attract कर लेते हैं, prevent them to move forward. Thus, motion of electrons through a conductor is retarded, slowed down by its resistance. A component of a given size that offers a low resistance is a good conductor. A conductor having some appreciable resistance is called a resistor. Okay, a conductor having some resistance is called a resistor. A component of identical size that offers higher resistance is a poor conductor. An insulator of the same size offers even higher resistance is called an insulator. Again, I have noted one question out here. Okay, define a resistor, poor conductor, good conductor of electricity, and give examples. Now you see, define a resistor, poor conductor, good conductor of electricity, and just one more thing. Instead of this, I'll write insulator. Okay, define an insulator. Define an insulator, poor conductor, good conductor. Example. Example देखो, a good conductor, aluminum wire and copper wire. Okay, an insulator, rubber. And even wood and rubber are good insulators. They have high resistivity. They will not allow the flow of current. Even plastic, insulator. Okay, good conductors of electricity. Poor conductor, water. Water is a conductor of electricity, but it is a poor conductor of electricity. It will allow some current to pass, but not completely. But you have to be careful with water. Pure water will not allow any current to pass through. Okay, but pure water में dissolved impurities होते हैं, salts होते हैं, ions होते हैं, salts and उसके ions. कभी कभी acidified होते हैं. That is why you see in chemistry we add a few drops of acid to pure water to convert it into a conductor. Otherwise it is a poor conductor. Pure water, distilled water. And of course rubber and wood are almost insulators. Plastic is almost an insulator. Very little current, उसकी resistivity बहुत high होती है. And finally, of course, aluminium and copper wires are extremely good conductors. Even metals, they don't have the same amount of electric resistivity. They have got different amounts. In other words, some metals are extremely good conductors, some are not so good conductors. Okay. Now this topic about factors on which the resistance of a conductor depends. It depends upon 2 or 3 major factors. एक तो temperature है, room temperature क्या है. At certain temperatures the resistivity is low and more current flows. The length of the wire, the length of the conductor, the area of cross section मतलब उसकी thickness. ये जो thickness है ना, this is called area of cross section. देखो my finger, okay, this part is called the area of cross section और thickness के ऊपर डिपेंड करता है. अगर वायर बहुत थिक है तो रेजिस्टिविटी विल बी वेरी हाई, रेजिस्टेंस विल बी वेरी हाई, द रिजल्ट ऑफ व्हिच लेस करंट विल फ्लो. Okay, if it is a thin wire, okay, area of cross section is less, it's a thin wire, and therefore less resistivity, more current will be able to flow. And resistivity depends also upon the length. If the length is large, the length of the wire is more current will be able to flow through it. Okay, so we'll discuss the factors on which the resistance of a conducting wire depends. We'll discuss it tomorrow and carry on further for it. Once again, okay, let me just repeat. These videos are all free right now. They're all completely free because of the pandemic. I've kept it free so that all students can take advantage of it. And that is why I'm saying those who are not subscribed, please subscribe to it so that you can get updated every now and then. Whenever, almost daily I send videos, so you should be able to watch them. Like the videos, make a comment. I like people making comments, even if it is just one short sentence. If you have a question, that's even better. Okay, just be positive about what you write. And finally, of course, watch the videos fully to get proper benefit from it. Right now classes have stopped, the schools are closed. This is the only way out. Okay, so please have a nice day. Okay, stay safe and keep watching the videos. Thank you.